Howdy and welcome back. So we just went through an example of this function problematic, which introduced a couple of the limitations of, say, using the stack exclusively to store all the data within our program. So what limitations did we observe? Well, let's say we want to store a collection of data in an array on the stack. Well, this could prove to be a limitation because in creating that array, we must know exactly how to allocate that array at compile time. So before we've even begun, say, reading data, maybe from a file. What if, like, each time we run this application, the number of objects that we're looking to read changed? Well, if we had to know the size at compile time, we have a couple of options. We could have created an array on the stack that was just huge and could maybe store a huge number of data points that we could potentially read. But that could be a waste of memory, because what if we don't always read that many number of objects? What if maybe in some instances we only have a handful? So the question becomes, like, could we somehow create objects to store such data at runtime? Could we actually construct or request an array of a specific number of objects be allocated to us while our program is running? And we'll see that the free store will allow us to do that. For instance, maybe we have this file and the first line says how many objects are within it. We could actually take that number and we could ask the free store manager, hey, I need an array of this size, and it would give us just that, provided the memory is available. This is something the stack can't do because it needs that consistency from function invocation to function invocation, and that each activation record is going to look precisely the same. So, second kind of limitation that we saw of the stack, and again, the first one is we don't have the capability to create variable length arrays on the stack. Second one, if we create an object or compound object within a function, so maybe it's an integer object or an integer array, the stack automatically deallocates space for that object once the function returns. So if we had an array on the stack, and let's say we're trying to follow good practice and we're going to go ahead and create this array within our function, we'll go ahead and read the data from the file and return the array. That memory is deallocated the second we hit that return statement. So how can we create something in a function and allow it to live well beyond that function, so after that function is returned? Well, we'll see here that the free store is going to allow us to essentially manage that memory. So we'd be responsible for the allocation. So we could say, hey, I want this object or this array of some specified size. And then that array will stick around until I explicitly request that its memory is deallocated. And again, this is how the free store will go ahead and address this limitation of the object in this sense that, okay, if I put something on the stack, its lifetime is automatically going to be controlled by the pushing and popping of the activation records onto that stack. So, the last point here is, could we somehow create objects that we control the lifetime of? Absolutely, and that's what I was getting with at the free store. Okay, so that concludes today's lesson. The next one will be on the free store and how we can address these limitations.